All right, going on to objective 2. Using combined variations. A combined variation, combines direct and inverse variations in more complicated relationships. So, look at the first example. See if we can kind of get this zoomed in. Y varies directly with the square of x. So y equals kx squared. Y varies inversely with the cube of x. So y equals k over x cubed. Z varies jointly with x and y. So z equals kxy. Z varies jointly with x and y and inversely with w. So that tells us z equals kxy over w. Z varies directly with x and inversely with the product of w and y. So z equals kx over wy. So reading the math, you can write z varies jointly with x and y as z varies directly with the product of x and y. So look that over, make sure you understand the verbiage and what happens in equation form. So real world connection says this. Newton's law of universal gravitation is modeled by the formula of F, which is the gravitational force, equals G m1 m2 over d squared. So F is the gravitational force between the objects of mass 1 and mass 2, and d is the distance between the objects. G is the gravitational constant. Describe Newton's law as a combined variation. So to say this, we would say F varies jointly with masses m1 and m2, and inversely with the square of the distance. So, geometry. The formula of the trapezoid is A equals 1/2 h times b1 plus b2. Describe the relationship as a combined variation. So you could say area varies, is it inversely? Are any of the variables in the denominator? No, so it cannot be A. A varies jointly with the height and the sum of the bases. That sounds pretty good. A does not vary. Okay, that's not true. And A varies jointly with the height only. That's not true. So we can say B. A varies jointly with the height and the sum of the bases. So that would be the height and the sum of the bases. Excellent. Okay, finding a formula. Okay. The volume of a rectangle tetrahedron varies directly as the cube of the length of an edge. The volume of a regular tetrahedron with an edge length of 3 is 9 square root of 2 over 4. Find the formula for the volume of a regular tetrahedron. So we can say V equals K E cubed. Okay, so we know the volume is 9 square roots of 2 over 4. And we know E, the edge, is 3. So K times 3 cubed. I say 3 cubed. So we're going to substitute so we can multiply. So 9 square root of 2 over 4 equals 27K. Divide each side by 27. So we can rewrite this as a square root of 2 over 12 equals K. So that's our K value. So our volume is square root of 2 over 12 times E cubed. Alright, let's take a shot at that one. The volume of a square pyramid, the volume is a square pyramid with congruent edges, varies directly as the cube of the length of the edge. Okay, the volume of the square pyramid of the edge length is 4, so E equals 4. And we know volume equals K E cubed. And we know volume is 32 root 2 all over 3. So let's just set our equation. So 32 root 2 over 3, that's our volume, equals K times 4 cubed. Okay, 4 cubed is 64. So we can say 32 root 2 over 3 equals 64K. Divide each side by 64. So it's going to be 32 root 2 over 64 times 3 equals k. 32 goes into 64 twice, so we can rewrite this as the square root of 2 over 6 equals k. So we can say volume equals the root 2 over 6 times e cubed. So the answer would be D. Okay, that concludes Chapter 9, Section 1, Part 2.